Hello and welcome to our development live stream for August 2019. And yes, today I'll be showing you the current development for the Spline proximity node that you have voted for a few days ago. And I have to admit, while we have the basic algorithm worked out, things are going to get a little bit tricky in making this work with VPR, making sure that live updates happen in a way that keeps Lightwave in a safe state, and so on. So let me just show you what we have so far. Um, this is a VPR render, and you can see if I turn on the OpenGL overlay that we have a spline here. And if I go to the surface properties of this plane that I've got here, it contains a principled BSDF, a gradient, and the gradient is driven by the spline proximity node. Currently, it allows you to pick one of the splines in the scene. There's only one. Evaluate in local and world coordinates. You can define a minimum and a maximum distance for a normalized output. And you have an option to evaluate the whole thing in 2D, and you can pick the axes to evaluate on down here. Most of the output options you can use are essentially not driven by controls here, but you have the direct outputs here. So from top to bottom, you have the distance. Let me just actually explain what the node does first. So basically, it takes an input position, which if you're shading is your current spot on the mesh that's being computed, and tries to find the closest point on the spline that's closest to the point that you're actually shading at the moment, and computes the distance for that. And that's what you get in distance output. The distance output is the distance to the closest point on the spline to your current point, which you can also modify with another input here. The normalized output is essentially taking the distance, but assuming that anything between your minimum distance and your maximum distance is equivalent to 0 to 1. So if I say the minimum distance is 1 meter, let's just edit this here, and the output, the maximum is 3 meters, then basically everything between any distance between 1 and 3 meters will be 0 to 1 on the normalized output. And as you can see, this actually doesn't clamp, but the gradient clamps. So a distance of, let's say, of 2 meters, which is in between there, would give you a normalized output of 0.5 because it's the middle there. The position output gives you the position of the closest point on the spline. The direction gives you the direction of the point that you're evaluating to that closest point on the spline. And the 2D distance, normalized position, and direction do the same thing, but they only limit the evaluation to either the YZ, XY, or XZ axes. And I've got another scene that will show how that works. So yes, that's what the node does so far. Hello, John. And the main issue I have at the moment is basically being able to edit the spline interactively while VPR is rendering, or even after VPR has rendered, because for some reason that is currently interfering with the spline editor. But let me just see if that works now, because I did actually work a bit more on the code. I had to actually. Yeah, that doesn't work. Let's see. There we are. So if I see, yeah, you can see it's not working. Normally, the spline should update to reflect the change in the position of this knot here. and it doesn't. And oddly enough, if I just load the scene, I can do it. As soon as I activate VPR, it doesn't work anymore. So yeah, let's just forget about the scene and to show you one more thing that I've also added, which is going to eventually be optional. Hello, Michael. Hello, Alessandro. Um, there's now an option to basically draw what I call a spline shadow, which is the spline, but along the planes around the origin, the X, Y, and Z planes, which doesn't make much sense here, but let me just load the other scene. There you go. And this is one spline. And you can see that the spline shadow drawing here essentially draws that spline in 2D along the major axes. And this is just going to be something that you can activate for editing. Currently it's always on, but yeah, there will be a switch for that. And I actually added that just to make the whole 2D evaluation thing a bit easier for me. So what we have here is we have a spline that is bendy in all 3 dimensions. We have 3 planes. These are just lightwave primitives. And if we look at the nodes for one of them, let's take the XY plane. It's again using the spline proximity node. And for XY plane is which one? Yes, for this plane here, the spline proximity node is evaluating along the Z-axis. So basically the normal of that object, of that plane. And it's also using a normalized coordinate that goes into a gradient. And if I render the whole thing, it looks like this. So essentially the 2D evaluation or the 2D outputs basically map the spline onto either an XY, XZ, or YZ plane. And you will see if I take this one, which is this surface here, and don't use the normalized output, but not the 2D normalized output, but the normalized output, I will get this, and this actually takes the distance of the spline from that surface into account as well, while 2D normalized just essentially assumes that the distance along the Z-axis from the spline to that surface is 0. So this will give you some extra options. And if you wonder why I added the direction, one idea, and I want to see if I can create a demo scene for that, would be to be able to push geometry toward a spline or away from a spline. That's something you could do with the direction input or output here, which would tell you in which direction to move the points. And if that works out and gives some decent results, then it will eventually end up being a more specialized node as well. And we might be able to do that this cycle. So as you can see, it's essentially working. The only problem I have at the moment is basically getting the spline edit to work at the same time. And also there's some caching issues in the background. One major change, or one big change from the last version of the Spline tools, is that something that I used to have in the beta version, which is the, where is it? And the Spline prefs. The evaluation steps, they're back now. And I did promise a drawing for tonight, so I'm going to draw an idea of how the algorithm works, so you kind of know what's happening there. But essentially, the spline is being subdivided, and from one knot to the next, it's being subdivided by this amount of steps, the evaluation steps. And these are used as a base to find the closest point, and then it's being refined further. So 32 is kind of okay. And you see if I really lower this to something like, I don't know, 4, you can see it's really starting to be super blocky here. And it's not, yeah, it's got its issues. And essentially, the higher the value, the more accurate it is. But also, the higher the value, the longer it's going to take to compute. But I think something like 32 is should be more than enough, and you can really push this up to something like 64 or so. And yeah, you see it's already taking a bit longer to update. But that's also a debug version, which isn't fully optimized code. Hello, Andrew. So yes, the evaluation steps are back. And also a piece of code I haven't quite finished yet. You can overwrite the evaluation steps per spline object. Normally use defaults, but you can change the evaluation steps here. I don't think that actually does anything yet. No, it doesn't. But eventually you'll be able to change them per spline object. And the interesting thing is, what the evaluation steps essentially are is there a cache of the points along the spline. And one thing this will eventually allow us to do, for example, is to measure the distance along a spline in real-world coordinates. So you could not just place something like you can do right now using the displacement, which goes from 0 to 100% along the spline, but you can also place something at 5 meters along the spline if the spline is actually that long. And the cache created by the evaluation steps here is going to be used to at least help compute that length. And there's a few mathematical functions on computing splines that essentially rely on evaluating many steps along the spline curve itself, because you can't really evaluate it natively. And as an example of that, I'm going to show you how the spline proximity code works internally. So let me just see. I had something. Yeah, there's something installed here called the whiteboard. So yeah, this makes me feel like it's school. If there's something I hated, it was always, walking up to the blackboard. All right. So let's just assume we have a spline, like so. And the spline has, let's say, a knot here, maybe one here, and there's another knot here. And the handles that we have are, maybe like that. Yeah, this one didn't even hit it. Can I undo this? Yes, I can. We have handles like this, and maybe a handle like that. So it's a spline which has 3 knots, which gives us 2 spans. And we want to find out what the closest point is to this point. So what the code internally does is first it computes the cache, and that essentially just steps along the spline, evaluates the positions there, and stores them somewhere. So it stores a position here, stores one here, stores one here, stores one here, stores a position there, and so on. All right. These are fairly evenly spaced. And internally, a similar cache is also being used to draw the spline in the viewport, and the blue lines are then just connected by what is essentially straight lines, which are going to be a bitch to draw in here. But yeah, these blue points are essentially, connected like that. So these are just straight lines. And as you can assume, the more points we have, the closer this approximation is going to be to the actual shape of the spline. Not only if I draw it like that, but if it's proper straight lines. But you can see there's areas here where the approximation is quite far off the spline, but there's other areas where it's close. So to find the closest point on the spline to our red point here, what it basically does is it looks at the distance to the first point, which is, let's say, this one. Then it computes the distance for this. Then it goes to the second point and computes the distance for that as well. Then it compares the distances. So if, let's say, the second point, this one, is closer, then it completely forgets about the first point. This one is completely ignored. And it keeps this one in memory and remembers it. Then it draws next or computes the next distance, again compares that to the previous one. If it's shorter, it keeps the current one, otherwise it keeps the previous shortest distance. And it does that going through the complete cache, trying to find the point that's the closest to our search reference point, which is a red one. So let's just assume that it eventually finds out that this point is the closest one. And it already knows the distance from here to here. Now, what we know at this point is that out of the points in the cache, all of these, we know that this one is the closest one to the point we're searching from. But there may actually be a point between this cached point and this one, or this cached point and this one, that is actually closer. So the next thing we do is basically the code creates two virtual lines in memory. One is a line from the current cached point to the previous one, like so. The other one is one from the currently cached point to the next one. And then it again, and that's a fairly simple algorithm, it basically tries to find the point on this line that's the closest to this point, which may be, I don't know, this point. And on this line, it also tries to find the closest point to this one, which in this case would actually end up being over here. And then it just compares the two distances. So this distance, oops, and this distance, picks the closest or the shortest one and says, all right, I've now found a point. Let's assume that it's the red one here. And this is actually the point within the cached line segments that's the closest to our reference point. Once this point has been found, and this by itself actually works fairly well already, especially if you increase the number of steps or lines in the cache. Once you reach 32 or 64, the lines in there approximate the spline so well that this is usually already sufficient. However, as a next step, what I'm doing is I'm basically finding the position of this point as a percentage along the spline. So I know that it's between the first and the second knot, and I also know that it's very close to the second knot, and I can essentially find out the percentage where this point is along our cached points. And if I use the same percentage to evaluate the actual spline, I can find a position that might just be a little bit more accurate and exactly on the spline, up there. And this is the position that the node is actually working on. And to be fair, I'm surprised that it works that well. It's not that slow. But one of the major downsides is that all of these comparisons basically happen in local space, which is okay if you're just doing a 3D comparison. However, once you do the 2D evaluations, which are just planar, then things get a bit trickier because I'm turning off axes in local space, but actually you would want to have them turned off in world space, and that in turn would require that whole sequence of cached points to be in world space as well, which they aren't. So you have to transform them, and that's just going to add a bit more cache management. But yeah, I think I'll get that sussed out. So yeah, the important thing here is just to be able to manage that cache of pre-computed points well, and to make sure that it's not being regenerated too often because it takes time. But you also want to regenerate it every time you have to, like if a knot is being moved in the spline editor. And you also have to make sure that it happens in such a way that it doesn't crash VPR. For example, if that cache of our blue points here is just being generated, you don't actually want to use it for rendering. You want to wait until it has been generated and then render. Or if it changes, you want to stop the render, make the changes, and then continue with the render. It's something that is possible in the SDK, but within all the spline tools and everything, you have to find the right spaces where you put that code, where you're actually affecting the cache and so on. And until 5 minutes before the stream, just because of that, I actually had a version that essentially resulted in an endless VPR refresh where nothing happened, just because there was one cache that was being created too often. So yeah, but this is essentially it. As you see by itself, it's a nice effect. And I think you can already do quite a lot with that, especially since this is going to work with lots of other nodal contexts as well, such as deformations. And yeah, it's also going to be excellent groundwork for further tools. And this will also allow me to stabilize the spline editor a bit more in terms of working with VPR being live. Because having VPR on and just using a spline as a motion path is very, very different from having VPR active and constantly evaluating a spline for rendering, because all of a sudden, at least on this machine, you've got 32 threads hitting the spline evaluation at the same time, as opposed to just one that updates the motions. And yeah, so far that's all I can really talk about. If you have any questions or comments or anything, oh yes, and two things. That idea with the shadow splines here with the drawing mode, that's from Lewis, who isn't here. So thank him for that. And yeah, thanks to Andrew for coming up with the idea, or at least a request to just evaluate the splines in 2D space, which is what makes something like this possible. Well, yeah, especially thanks, John. John just said very nice to control neon light animation and illumination control, especially if you use nice gradients like I do. I'm just going to take a sip and see if any of you have any questions, suggestions, gripes, whatever. Oh, come on, we can't have 10 or 9 viewers here. Nobody has a question. I think I need a soundboard that plays a cowbell sound. But yeah, as I said, the interesting thing here was that this algorithm I sketched out actually did work quite well, and I've what do you mean, just one good idea per week, or what, Andrew? Um, I mean, and especially in the last 2 months, I did read a lot about Bezier splines and evaluating them and things like that. And I was quite surprised that there wasn't a more mathematically elegant way to find the closest point. But apparently, that brute force method is what everybody does. I mean, even experts on it. And the interesting thing is that they actually don't do the last step of finding the closest point on the cache and then using that information to re-evaluate the original spline to find a closer match. No, not yet. Um, well, first of all, the spline itself doesn't render yet. But yes, I have thought about that. Um, in the sense of the evaluation node, I mean, there's probably going to be two different, or there could be two different approaches to the whole spline growth because yes, it is, Andrew. The point order is calculated in the cache. Um, there's basically two things that could be done. Um, One would be to have a basically start end evaluation percentage within the node that evaluates the spline. Or one thing you could do is add a basically start and end evaluation slider percentage to the spline primitive itself. That would mean that everything that evaluates the spline has the same start and end points along that spline. The downside is, of course, that if you want to reuse the same spline but with different settings, you will not be able to do that with that method unless I start implementing spline instances, which is not the same as instances on spline, but splines within the system that can be instanced. Um, that growth thing or the evaluation range, if it's going to be added, I think it will be added as a property of the spline itself. And then everything that evaluates it will have the same range of the spline to evaluate. And I think we're probably going to collect a few small, in I'm doing air quotes here, a couple of small suggestions like that, maybe bundle them together in one big packet and say, okay, there's lots of minor improvements that we can do in the whole tools, bundle them together and then just do them in 1 month. But I do prefer the idea of limiting the evaluation range on the spline primitive, because otherwise you will have an evaluation range, need to have one on every node, on every tool that actually uses the spline. So let me just write that down. I just hope that I'll be able to read it later as well. Um, what do you mean by the point order, Andrew? I mean, the point order is essentially it's taking the knots from the first knot to the last knot, and that's used to create the cache. It's just a sequential. It's basically just a big memory block of 3D space coordinates from a start to a certain end. Well, the idea with the spline evaluation is that just like you have the displacement right now, and I mean the spline displacement used to evaluate it to find a position on the spline. If you have and it goes from 0 to 100%, where 0 is the start of the spline and 100% is the end of the spline, then you could basically use those two values to drive which range of the spline you want to use, if that makes sense. So you could say, okay, I want to start evaluating the spline 20% away from the start up to 70% of the length of the spline. And then it's just going to evaluate what's in between the 20 and the 70% range. Well, this will work with displacement. The only question is which direction it displaces, and currently it displaces straight toward the spline if you're using the direction vector, but I still need to work out a scene for that. I could. That depends on how the 3D spline rendering is going to work. And it probably wouldn't affect something like the proximity itself, because that's just a distance to the line, and the spline in that evaluation doesn't have a thickness. But once we get to something like rendering those splines as 3D, either by directly rendering them or by creating geometry out of them, then a weight per knot is certainly possible. Yeah, I mean, I can just add data to whatever I want to, which is one big advantage of writing that completely on your own. That's, yeah. The question is how that would scale, because it would essentially need to, I don't know, multiply the computed distance or something like that. Not the gradient itself, but the distance on that's used to drive the gradient. But I'll certainly write that down. Weights for knots. As long as it's not weights for nuts. No, that's for Alessandro. Hello, Carm. Nice to have you here, and hello, Steph. And yeah, also one thing that I will need to add that's more spline editor related, that's actually not in there. Don't ask me why. There's actually no way to reverse the spline direction. Nothing. I mean, essentially all I need to do is basically swap the in and out control points for the knots and just put them back into the same array where I have them with the reverse order, and that's it. But that actually doesn't exist at all. So yeah, I mean, this is essentially going to be it for this month. It's this node is making sure that it actually works with VPR, working a bit more on the caching system so that it computes less and only when it needs to. Chrome seems to work, and I think, I'm not sure if Dagmar still uses Firefox. I think Edge works as well. I mean, Internet Explorer. Yeah, so basically make sure that the whole editing process works with VPR, and I hope there's nothing on UTEX's side that prevents it from happening. That's one part. Then making sure that the cache generation is as efficient as possible. Probably not 100% efficient, but close. I mean, well, one thing I'm doing right now is if in the spline editor you move one of the knots, that it just recomputes everything, and that could certainly be limited to only recompute the values in the cache that are affected by the knot, which is just the spline to the previous and to the next knot. But yeah, that might be an exercise for later. And if I still find a bit of time, I might be able to add a basically not a deformer node, because that's very different, but something like an influencer node where you can push vertices toward a spline or pull them away from a spline, which is essentially just going to be a more specialized version of the proximity node. Well, I hope that everybody else is getting the video as well, or just listening to me. But Andrew seems to see something. All right, yeah. So that's essentially it. And yeah, the main gripe that I still have is that, you know, when I'm actually moving this, it should actually update everything, and I haven't got a clue why it doesn't. And just to prove it to you, let me just reload the same scene. Here we go. If I go to the spline editor now, select this, see, it updates. It works. It works. But if I press Control F9 now, and do the same thing, oh no, it works as well. Now, this is essentially what should happen. I'm just not sure why it only does at times. But yeah, this is the very much desired result, I suppose. So let's see if I drop the spline tool, activate it again. Nope, that's wrong. Yeah, see? Now it doesn't anymore. Whatever. Whatever. No, it didn't. It didn't fix anything. Because in my tests, what I didn't do is keep the tool on and then activate VPR while the tool is on. I always had VPR on first and then activated the tool. And at this point, I'm absolutely stumped. But yeah, I'll hopefully figure it out. I hope. Otherwise, you know, talking about spline knots, maybe I'll need to kick somebody in the nuts. I don't know where it is. I have no idea. Yeah, yeah. It's something about something. Michael, I hope it was obvious enough. Need a snake in the grass. Um, not at the moment. Eventually, you will be able to. If you want to do it now, get Hoser. But eventually, there will be a spline deformer that allows you to actually move the snake along in the grass and have it deform along the spline. And once we have animatable splines, which is also a prerequisite for deformer, then you will be able to do a hell of a lot more. For example, especially once we have the ability to limit the evaluation range for the spline, you could use something like the push-pull effector to push down grass and have that animated along the spline by animating the evaluation limit of the spline. Or Boatwake, yeah. Yes, you can animate values along the spline because that's what the original spline evaluation node does. Let me just drop this. I mean, this is, I mean, if you just want to animate something along a spline, you can use something. All right, this is using spline. I'm not sure. No, this is using normal spline motion. Which one was it? I think this is using the motion plugin as well. Yes. No, it's not. Okay. I mean, if you want to attach a texture to a spline, you can just use the spline evaluation and basically use that to drive the position of a texture. Rosa doesn't work anymore. That's a shame. To have a second spline along a spline, but then have an undulation. What do you mean by undulation? You mean one for alignment or one to shape the deformation? Would that be... using one spline to deform another? No, because you would actually need to have a nodal evaluation of the knots on the db&w spline. That's where it gets tricky. Because, I mean, I know what you're trying to say. One thing that could be possible is to have like a node editor on the spline primitive that allows you to change the position of the knots. So you could evaluate another spline within the node editor of this spline to modify the points. Also, another option, and that's something that could be added to the motion evaluation as well, is to basically have a main spline as well as a rail spline, which basically a second spline that runs along the main one and maybe defines the alignment, or could also define thickness. And you could use that for deformation. So you have a main line, a main spline that defines your basic deformation along that spline, and a second spline that runs along it, and the distance of the first to the second spline basically that defines the scale of the deformation. Yes, it was part of Taft. And there's also a very, very nice spline node by Dennis, but unfortunately that's also just limited to deformation. And one thing I wanted to avoid with this is just, you know, create one node that does spline deformations, but then there's so many other things you can do with splines, and you would have to reinvent the wheel every single time. And the nice thing about this approach is that hopefully, you know, you have one basic toolkit to deal with splines, and then lots of different applications for that you can dock onto the main spline toolkit. Oh yeah, and writing out and stuff like that. Um, I mean, all of the spline evaluation limits, that's very close to the write on, write off that you have for splines in Fusion. And also the animation of splines will also be very similar to the way you do it in Fusion, where you can just animate the whole shape and set a keyframe for the whole shape as opposed to different knots individually, which will probably also be an option, but yeah, that's another story. I see that you're really getting excited about this, so this is good. Good to see. To be fair, we are as well. All right. Um, well, we are 48 minutes in, and I would say that if you don't have any more questions, we'll just call it a day or an evening. And thanks to all of you for watching. It's nice to see that many people online. And you all know, if you want to follow the development a bit closer, join the Discord. I usually post a couple of screenshots per day when I'm working on the db&w tools. And yeah, you can do plenty of cool stuff with this. All right. Well, see, we had food already, ADP. I have to say, I really like Hoser. And one reason why I like it is because you don't actually have to mess with tangents or anything to get, a nice looking spline out of it. And in a way, with the auto smoothing, that's something I tried to preserve in the Spline Toolkit here as well. Because once you do get to actually be able to animate it, then you don't want to animate the handles either. You just want like a hard or a smooth transition in your spline, and not bother to update the control handles on every knot, just to get the smoothness you actually want to. And I should stop talking. All right, so thanks everybody for showing up. It's been great seeing that many people. And as far as releasing something, I mean, the next Q&A should be next Friday. And yeah, I'll try to get you a preview build before that. If I can find out what the VPR issue is and make sure that it's at least stable. It might not run at the best speed that's possible, because the cache might be recreated too often, but at least it's going to be fairly stable, and the spline editor works in VPR. And once I've got that sussed out, then I'll send out a preview build for this month. It is. Thanks, Mike. Uh, yeah, as I said, I mean, there's so much you can do with splines, and I think they should be exploited more in 3D. All right. Thanks a lot. See you guys around, and yeah, at the latest, by next Friday. So have a nice evening, nice afternoon, nice morning, whatever. Bye bye.